Welcome you all. In this session, we will discuss about the concept of entropy. We have already discussed the entropy is property, and we have derived this equation. This equation we have already derived, right? In this condition, basically there are two conditions. First condition, ds is equal to dq by t, and next condition, ds greater than dq by t. So this condition is for reversible process, and this condition for irreversible process. We have already seen this one, right? Okay. Now, actually, we have already proved that entropy is property. Entropy, we have already proved that entropy is property. We have already proved that. That means entropy does not depend on path. Okay, this is a point function. This implies entropy is point function. Okay, so it does not matter whether this process is reversible or not. Suppose that, look at this figure in this diagram. Suppose that we have to find the change in entropy of this. There are two processes, the process 1 to 2 and process, there are two different paths. This is 1A2 and process 1B2, right? This 1A2 is a reversible process and 1B2 is irreversible process. Dotted line represents irreversible process. Therefore, since we have already seen that entropy is property, that means it does not depend on path. So this entropy change for both process will depend upon the initial and final point. It does not depend on path. Whether it is for reversible path or irreversible, it does not depend on path. So whenever we have to find the entropy change for any reversible path, irreversible process, then what we have to do? We have to replace this irreversible process to reversible process, right? We have to just in this figure, we have to change this. Suppose that this way 1B2 is the irreversible process, okay? And we have to find the change in entropy. We know that entropy does not depend on path; it is a point function. Since point is same, in this condition, we have to replace the irreversible process by reversible process, okay? So if by replacing this one, just we will find the change in entropy for irreversible process. Just I am repeating once again. This is very important. Suppose we know that entropy is property. It does not depend on path. It is point function. That means if initial and final point are same, it does not matter from which process it is being followed. Suppose that we have to find the entropy change for irreversible process. Okay. Since irreversible process, this path will be irreversible. If we know that entropy is property, it does not depend upon the process. Therefore, if we replace this irreversible process by this reversible process, then in this condition, what will happen? This will get the entropy change. This is S2 minus S1. So it is written here. Therefore, this entropy change for this one, this is S2 minus S1, right? So as entropy is property, it is written here, as entropy is property, it depends only on endpoints, and hence as long as the endpoints are same, entropy change remains same for reversible as well as irreversible process. Therefore, in order to find the entropy change for irreversible process, it must be replaced by reversible process between the same endpoints, right? So this is clearly explained here. Okay. Now we have to find the entropy change for system for reversible process. This is just we are discussing for reversible process. We know that this entropy, this is equal to ds is equal to dq by t. This is only for This is only for reversible process. We know this one. Okay. If heat is added, let us suppose in the first case, suppose that if heat is supplied, in this condition, what will happen? This dq will be positive because this heat is supplied. Whenever heat is supplied, this dq will be positive, and temperature is always positive. In this condition, this ds will be positive, and we can say that this entropy will be increasing. Okay. Therefore, whenever heat is supplied, entropy of the system will increase. Okay. Because when heat is supplied, this dq will be positive, because we know as per sign convention, whenever heat is applied, this sign will be positive. Okay. So therefore, whenever heat is applied, entropy change will be positive. Entropy of system will increase. Right? When heat is rejected, that means this dq will have this negative sign, and we know that this temperature is positive. Therefore, this ds will be of negative sign. In this condition, we can say that whenever heat is rejected, the entropy of system will decrease. Right? This is the third case. In third case, this is for reversible additive process, because we have already know that this ds is equal to dq by t for this is for reversible process. Okay, this ds is equal to dq by t for reversible process, and we know that for adiabatic process, if process is adiabatic, that means there is no heat exchange. Okay, no heat exchange. Okay, if there is no heat exchange, that means q is equal to constant. So in this condition, dq will be 0. In this condition, what will happen here? This ds is equal to 0. ds is equal to 0 means s is equal to constant, right? This implies entropy is constant. So this entropy is constant. This process is called isentropic process. So in this process, when the process is reversible adiabatic, this process is also called isentropic process. Why? Because it is already clear that for reversible process, ds is equal to dq by t, and for adiabatic process, there is no heat exchange. That means ds will be 0. ds will be 0. That means s is equal to s constant means entropy constant. So this is the process. That means in reversible adiabatic process, entropy will remain constant. Therefore, this process is also called reversible adiabatic process. Now we will see the entropy change for universe, right? So entropy change for universe, basically our universe is assumed as isolated. This is our assumption. This is very interesting assumption. Our universe is assumed to be isolated. Okay, let us discuss further. So first of all, let us suppose this is a system. This is our system, and everything except this system is called surrounding. When we add both one, this is called universe. Okay, this equation we know that this ds greater than or equal to dq by t. Okay, since our universe is isolated system, this is our assumption. That means there is no heat exchange between our universe to the place from where vacuum starts, right? So our universe is assumed to be isolated, therefore this dq will be 0, right? For isolated system, this q will be constant, and this implies dq will be 0. So in this condition, this ds universe is greater than or equal to 0 because this dq is 0. So we know that this universe consists of system and surrounding. Therefore, this equation ds system plus ds surrounding greater than or equal to 0, right? This equation is very interesting. So in this condition, what we observe here, the entropy of system may increase or decrease or remains constant. Similarly, the entropy of surrounding may increase or decrease or remains constant. But entropy of universe will always increase. This is very important, because in this equation it is clear that the entropy of a system and surrounding always greater than equal to 0, right? And we know that in reversible process in our universe there is no any reversible process. Okay, in our universe there is no any process exactly reversible. Therefore it can be written ds system plus ds surrounding this is property ds surrounding is greater than 0. Why? Because we know that this equality, this sign of this equal will be removed from this equation, because this equal is only for reversible process, and in the universe there is no process is reversible. Therefore this is important. In this condition ds universe always greater than 0. So in this condition, this is from this equation, it can be concluded that entropy of universe will always be increasing. There might be chance that entropy of system may increase or decrease. There might be chance that entropy of surrounding may either increase or decrease, but entropy of universe may never be decreasing. Its entropy will also be increasing, right? This is called principle of increase of entropy. Okay, therefore entropy of system can increase or can decrease, or it remains constant. Similarly, the entropy of this surrounding can increase or it can decrease or it can remain constant. But overall, the change in entropy of universe can never decrease. This is known as principle of increase of entropy, right? This is very important question. So this is principle of increase of entropy. Now this representation of this Carnot cycle on TS diagram. Just we have already explained this Carnot cycle on this PV plot. The process 1 to 2 is reversible isothermal expansion. Process 2 to 3 is reversible adiabatic. Then we can say that this is isentropic expansion, right? This reversible adiabatic process is isentropic. We have already explained. So the process 1 to 2 is, this is TH, reversible isothermal expansion or reversible isothermal heat addition. Process 2 to 3 is isentropic expansion process. 3 to 4 is isothermal heat rejection, and 4 to 1 is isentropic compression. This is already we have explained on PV plot. Okay, on TS plot it can be explained like that. Since process 1 to 2 is isothermal heat addition, so this isothermal heat addition, this line will be horizontal because this temperature is constant. This from where this temperature is TH, right? So this 1 to 2 is the isothermal process, this isothermal heat addition process. So this temperature will remain constant, and we know that whenever heat is added, entropy will increase. Already we have explained earlier. Whenever heat is added, entropy will increase. Therefore, in this process 1 to 2, the direction will be left to right, so that entropy may increase, right? Entropy will increase. So be careful in direction. The process 1 to 2 is isothermal heat addition. Isothermal process, that means temperature will constant. Therefore, this line will be horizontal. And whenever heat is added, we have already seen that ds is equal to dq by t. Whenever heat is added, this dq will be positive sign. dq will be positive sign. In this condition, ds will be positive. That means entropy will increase. So therefore, this entropy will increase. Right? The process 2 to 3 is isentropic expansion. Whenever gas is expanded isentropically, this temperature drops. Okay, this temperature drops from Ts to TL. So temperature drops from Ts to TL. Drops from Ts to TL. Right? 2 to 3 is the isentropic expansion, right? In this process, during expansion process, temperature drops. Okay. Next process 3 to 4 is constant temperature heat rejection process. Therefore 3 to 4 is the constant temperature heat rejection process, and this temperature is TL. Therefore this line will be horizontal, and we know that whenever heat is rejected in this process, heat is rejected, therefore entropy will decrease, right? Therefore entropy will decrease. Therefore this direction will be from right to left. Okay, and this 4 to 1 is this isentropic compression. Whenever air is compressed, this temperature will increase. You know that whenever air is compressed, this temperature will increase. Therefore this reaction will be in upward direction. Okay, so in this process 1 to T, this constant temperature heat addition process. Process 2 to 3, isentropic expansion. Process 3 to 4, constant temperature heat rejection, where temperature is TL, and 4 to 1 is isentropic compression. This is the process on TS plot, right? This is important. We need to understand this Carnot cycle on TS diagram also, right? Now this is the combined first and second law of thermodynamics. We know that this dq is equal to du plus pdv. This is for process, we already know. dq is equal to du plus pdv. This is for reversible process. Why? Because this pdv is only for reversible process. This is only for reversible process. So therefore dq is equal to du plus pdv. Okay, and we know that ds is equal to dq by t. This is for reversible process. Therefore this dq is equal to tds. dq is equal to tds. This is for reversible process. We know from this second law. From first law, dq is equal to du plus pdv. From second law, dq is equal to ds. This is for reversible, because for reversible process ds is equal to dq by t. Okay, for reversible process ds is equal to dq by t, right? Therefore this dq is equal to ds. Okay, so this equation valid for reversible process. So we have to replace this dq by tds, right? So it can be written this tds is equal to du plus pdv, right? This is very important question. tds is equal to du plus pdv. This is the combination of first and second law, because as for first law we know this dq is equal to du plus pdv, and from second law we know that this dq is equal to tds. Therefore it can be written tds is equal to du plus pdv. Okay, this is the combination of first and second law, right? This is already explained here. This equation is applicable only for any process. Why? Because everything, whatever this quantity is here, all are property. Okay, so this tds is equal to du plus pdv. This is applicable for all process, both reversible and irreversible, because it consists of various properties. Because temperature is property, entropy is property, internal energy is property, pressure is property, and volume is property. All are, this equation consists of the combination of these properties. Therefore this equation is valid for both reversible and irreversible process, right? So this equation is very important. This tds is equal to t plus vdp. Simply we have to replace this dq by this tds. One more equation, just we will see here. We know that this is h is equal to u plus pdv. Small h, this is a specific enthalpy. Okay, u small u specific internal energy plus p into a small v. This is a specific volume. This is per unit mass, because you know that capital H is equal to u plus pv, and when we divided on mass, h is equal to u plus pdv. Okay. So this is the same equation is written here. H is equal to u plus pdv. Simply we have to differentiate partially. Differentiate partially. If you differentiate partially, what you will observe here, this dh is equal to du plus pdv plus vdp, right? And we know that du plus pdv, this dq is equal to du plus pdv. So we have to replace this one. du plus vdp by this dq. So this dh is equal to dq plus vdp. Okay. Therefore, and we know that this dq is equal to tds. Okay. This dq is equal to tds. Therefore, this dh is equal to tds plus vdp. So finally, tds is equal to dh minus vdp. This is very important equation. So this tds is equal to dh minus vdp. So once again, this is the important equation. TDS is equal to dh minus vdp. So we have two equations. TDS is equal to du plus vdp and TDS is equal to dh minus vdp. Simply we have to this H is equal to enthalpy. Enthalpy is the summation of internal energy plus displacement work. We have to partially differentiate this equation and we have to replace by this dq and TDS. We will get TDS is equal to dh minus vdp. So this equation is applicable for both reversible and irreversible process because it consists of this all are properties. This consists of different properties. Temperature property, entropy property, enthalpy property, specific volume property, all are combination of these properties. Therefore, this equation can be applicable for all reversible and irreversible process. Okay, right. Now, representation of constant volume and constant pressure line on TS diagram. This is important. This equation you know, TDS is equal to du plus vdp. Okay. Suppose that there are two processes. Okay. There are two processes. In one process, the pressure is constant. In another process, volume is constant. There are two processes. Okay. Let us suppose in first process, volume is constant. Okay. So there are two choices. We have two equations. This TDS is equal to dh minus vdp and another is TDS is equal to du plus vdp. Since volume is constant, so let us pick this equation. TDS is equal to du plus vdp because when volume is constant, this term will be 0. Right? So let us pick this equation. TDS is equal to du plus vdp. Since volume is constant, therefore volume dv will be 0. So du is equal to, and we know that this du is equal to cv dt. So when put this value in this equation, this TDS is equal to du is equal to cv dt. And this will be 0. So TDS is equal to cv dt. Therefore, dt by ds is equal to t by cv. This is equation number 1. This is for constant volume process. This equation for constant volume process. dt by ds is equal to t by cv. Right? Now, okay. So what is this one? Let us suppose this x is t and this is s. So what is dt by ds? dt by ds is slope of curve. Slope of curve. Let us suppose this is x axis, this is y axis. dt by ds is just like dy by, you can say that dy by dx. This is the slope of curve. So one process is isoporic and another is isobaric. We have to find which one is isobaric and which one is isoporic. So this is the for isoporic process, for constant volume process, the slope is t by c. Okay. Therefore, the slope of constant volume line on TS diagram is t by c. This is equation number 1. Similarly, for constant pressure process, this equation you know TDS is equal to dh minus vdp. We have to pick this equation because pressure is for constant pressure process. This pressure is constant. In this equation, this dp is there. Therefore, this term will be 0. Since pressure is constant, this dp is 0, and we know that this dh is equal to cp dt. Therefore, this TDS is equal to cp dt, and dt by ds for constant pressure process, this is t by cp. Okay, so this equation for constant pressure process. Then that means for constant pressure process, the slope will be t by cp, and for constant volume process, the slope is t by cp. We know that the cp is, you know that cp greater than cv. cp is greater than cv. Yes, cp is greater than cv. Therefore T by Cp is less than T by Cv. Is it clear? The slope of constant volume process is T by Cv. The slope of constant pressure process is T by Cp. And we know that Cp is greater than Cv. That means the slope of isobaric process is less than slope of isochoric process. And in this process, this curve have more slope. This curve have more slope. That's why this process will be isochoric and this process will be isobaric. Okay, so whenever two curves are plotted on TS plot and we have to find which one is isochoric and which one is isobaric, this slope having more curve, this curve having more slope will be isochoric process, and the slope and the curve having less slope will be isobaric process. Because we know that the slope of isochoric process is T by Cp and slope of isobaric process is T by Cp, and the Cp is greater than Cv. That's why slope of isochoric curve will be more than that of slope of isobaric curve. This is very important discussion. Right? Now entropy change for ideal gas. We know that this Tds is equal to du plus Pdv, and therefore this ds is equal to du by t. This Tds is equal to du plus Pdv, we know, right? Therefore this ds is equal to du by t plus p by t dv, right? We know that this du is equal to cv dt and pv is equal to rt. Therefore p by t, we have to replace this p by t is equal to r by v. Simply we have to put this equation. Therefore ds is equal to ds is equal to cv dt by t plus r by v dv. Just simply we have to integrate this S1 to S2. This temperature is T1, this T1 to T2, and this V1 to V2. Therefore, this S2 minus S1 is equal to Cv ln T2 by T1 plus R ln V2 by V1. This is very important equation. Simply we have to use this equation and just simplify. By using this concept, du is equal to Cv dt and P by T is equal to R by V. These two things we have to put and we have to integrate. Therefore, this S2 minus S1. Therefore, S2 minus S1 is equal to Cv ln T2 by T1 plus R ln V2 by V1. This is one equation, right? And similarly, this is another equation. Let us equation number 2. Td is equal to dh minus vtp. Therefore, ds is equal to dh by t minus this is small d, right? V by t dp. We know that this dh is equal to cp dt and v by t is equal to r by p. Simply we have to put in this equation. Therefore, ds is cp dt by t minus r by p dp by p. Okay. Simply we have to integrate this one. So finally, after integrating, this S2 minus S1 is equal to cp ln T2 by T1 minus R ln P2 by P1. This is another equation. Okay. So another equation is S2 minus S1 is equal to Cp ln T2 by T1 minus R ln P2 by P1. This is another important equation, right? Okay, we will meet in next session. Thank you.